Okay, guys, in this lesson, we're going to talk about how to create a linear model in the form of a linear equation, and then we can use it to answer some questions. So let's recall slope-intercept form is the form we will write our models in. M is the slope, but in context, we're going to use the phrase constant rate of change, and our B value is the y-intercept, but this time, when we are talking about word problems, we're going to use the phrase initial value. So our first example, we have our topic is Christmas trees. We can see our x-axis represents months and our y-axis is total height. So x is months and y is total height of the tree. So the initial height of our tree when it's planted at month 0 is 2 feet tall. What is the growth rate? So we need to find the slope. So I'm going to pick two nice points that I can easily identify, 0, 2 and 12, 5. So slope is y2 minus y1 over x2 minus x1. We get 3 over 12, which simplifies to 1/4. So that means each month the tree grows 1/4 feet. We put this all together to create the model. This is our model. Now we can use that to answer some questions. How many months, which is x, will the tree grow until it reaches the maximum height of 14 feet? So we know the y value, 14, that represents total height, but we don't know x is asking for months. So we're going to isolate x. We're going to subtract 2 from each side. Then to undo this multiplication of a fraction, we're going to multiply by the reciprocal. And x equals 48. So 48 months. How many years is this? Well, there are 12 months in a year, so that equals 4 years. How tall will the tree be in 2 years? Well, in 4 years, it's 14 feet. Half of 4 is the 2 years, so half of 14 is 7. Okay, let's go to our next example. Here we have the topic is Christmas candy bowl. Our x represents days and y is total, now this is important, total candy in the bowl, because on day 0 we have 60 pieces in the bowl. It's not how many that have been taken from the bowl. So we have 60 pieces that we're starting out with. That's the initial amount. How many pieces are eaten in a day? So we're going to take 2 ordered pairs to find that rate of change. I'm just going to pick this one right here. So 12, 24. Our slope, y2 minus y1 over x2 minus x1. So we have negative 36 over 12, and that gives us negative 3. So there were 3 pieces eaten each day. When we write the equation, we will use the negative. So now we can answer some questions using our linear model. How many days, that's x, will it be when the bowl is empty? So the value for empty is 0. So when y is 0, so we're going to plug in 0 for y and solve for x. We get negative 60 equals negative 3x, divide, and x is 20. So 20 is this value right here, so our x-intercept. On what day is there half the number of pieces as there was on day 0? So on day 0, we had 60 pieces. On what day is there half of that? So we can look at the graph. We could look at day 10, but that would be hard to see. So we're just going to plug it in. Y equals, we're looking for total pieces. And on what day is there half the number of pieces? Oh, no, we need to go the other way around. So we need to read that carefully. On what day, so that tells me right there, I'm looking for x. I don't know x. And I want to know when there's half as many as 60. So we're going to solve. And that's day 10. And we could have just halved this 20, but I like to show the algebra. But don't make my mistake. Make sure you know which variable they're asking about and what value they give for the other variable. Okay, here we have Paul's piggy bank. Our X represents weeks and Y represents total savings. What is the initial amount? Well, it's kind of hard to know exactly, so I am going to skip to the next question and find the rate of change. So I need two identifiable ordered pairs. So that is 3, 80, and we have 7, 120. So our rate of change, slope, is 10. So he saves $10 each week. So I have y equals 10x plus b. I don't know the b value, so we're going to pick one of these points and plug in for x and y. So I'm going to plug in 80 for y, 3 for x, and solve for b. 10 times 3 is 30. Subtract 30, and we have isolated b to equal, 50. So he starts with $50. So we put that all together. So $10 each week plus the 50 he starts with. What is his savings in 1 year? So it's asking for savings, that's why. So we need to plug in weeks for X, but it's asking for a year. So there are 52 weeks equals 1 year. So we're going to plug in 52 for X, and we get 520 plus the initial amount, and we have a total of $570. He wants to buy a new iPhone that costs $1,250. How many weeks? So we're looking for X. Will he have to save? So I have a total amount, so I'm going to plug that in for Y, and we're going to solve for X. So subtract out the 50. And X equals 120. So 120 weeks. Okay, guys, our last one. We have Bluebell ice cream. We can see that it is decreasing. Our X is days, and our Y is total scoops. Now, this is important again, in the carton or the tub. Okay, so on day 0, we have 20 scoops. How many scoops eaten each day? So let's pick 2 points. So we have 0, 20, this point. And then we can have when the ice cream is gone on day 5. And our rate of change is 0 minus 20 over 5 minus 0. We get negative 20 over 5, which is negative 4. So how many scoops? 4 scoops are eaten each day. We're going to include the negative with our linear model. And now let's answer some questions using our equation. How many days if there are no scoops left? Well, we can clearly see it's 5, but let's do the math. So it says how many days, that's X, until there are no scoops left. So we're going to use the value 0 for Y. And we're going to solve for X. Divide by negative 4 on both sides, and we see that it is that 5. If the tub started with twice as many scoops, how many days would it take? So again, how many days, looking for X, would it last before running out? So we're going to plug in. So we're looking for scoops. So here's our new equation. So we have a new initial value. We want to know when there are 0 scoops. So let's isolate the x. Divide by -4. And x equals 10. So 10 days, which makes sense. Okay, because 5 days for 20. So if we double the 20, we double the 5.